Before I get into the topic for this talk, I'd like to introduce myself a little bit. My name is Kuemmel. I'm project manager and senior software consultant at MicroStream. I'm a software developer for around 13 years now, and as I said, at the beginning of 2019 I moved to MicroStream, and at the moment I'm project manager for the cluster development of MicroStream. And one question at the beginning: who of you already knows MicroStream or used MicroStream before? Oh, that's great. Okay, no problem, because here are the topics. I divided the presentation in, I would say, 3 or 4 parts. I would say the first part, only 5 minutes. I like to introduce Eclipse Store or MicroStream a little bit for those of you who didn't work with that in the past. But for all of you, you already know or familiar with MicroStream, no worries. It's only 5 minutes, and that's it. Then I moved to the different architectures that we have in the IT, and I think it's more about talking about replication for dummies, to tell you what are the pros and cons of replication, and what is the biggest thing behind replication, and cluster, of course. Then let's talk about ideas, our ideas of our cluster, how to use it, how it works, and so on. Then we do a short live demo. We will deploy one project to the cloud and see how it works. And after that, we talk a little bit about architecture and the roadmap of our cloud solution. Okay, so let's move on. Some of you might a little bit confused about the naming. We always talk about Eclipse Store and MicroStream and what are the differences. Just a short explanation: MicroStream was the product name before we donated that product to the Eclipse Foundation. But in that specific case, MicroStream stays the same because the solution within the cloud, within the cluster, is definitely MicroStream, and it's closed source because of all that replication stuff behind the scenes. Okay. So what is Eclipse Store or MicroStream basically? It's a Java native micro-persistence layer. That means it's a framework and it's part of your application, and yeah, it's inside your Java virtual machine. It's a framework. You can add it via Maven, and yeah, you can use it on every Java application, on every Android application, and also on microservices, of course. So, and as you can see here, it's a part in between the RAM and the JVM, and yeah, what it does is it enables you to store, or let's say synchronize, any object graph of any size or complexity directly to a binary format. And the binary format in that case could be stored, the easiest thing is to store it on a persistent volume, for example, or to store it on any binary blob storages like AWS S3 bucket or Azure storage or something else. But there is also a possibility to store stuff directly to relational databases like PostgreSQL, MySQL. Some of you might say, okay, why is that? Or does that make sense to store it in a relational database? Of course, some of you already have a relational database in place, and there are some backup functionality behind the scenes. And then it could make sense to store those binary files directly to the database and use that backup functionality at the end. So it's possible, you can use it. But to be honest, most of our customers use it on AFS or persistent volumes and store the data directly to the hard disk. And they do backups to the blob storage, AWS S3 bucket, or stuff like that. Okay. Another topic a lot of people ask us, how could this work to have everything in the RAM? So MicroStream or Eclipse Store is an in-memory database. Is that possible? There is the possibility to add lazy functions or lazy elements within your graph, and this data stays on the hard disk as long as you need it. So that means it looks like this. So let's imagine we have 1 million objects, for example, on our storage, but in the RAM we have only a few of them. So, and whenever you match an object at the edge of that graph and you call a get method, this data will be loaded from the hard disk. And this is the case where objects are merged automatically in your object graph in the RAM. Okay, this is what MicroStream basically is, or what Eclipse Store basically is. And now we have to talk about architecture a little bit. So if you have any question, please wait for the end of that presentation. That makes it easier for me to answer. Okay, let's talk about architectures and pros and cons of architectures. And what is this? This, I would say, is the good old monolithic application. We have some business logic somewhere, we have a UI somewhere, we have RAM, and we have Eclipse Store as I explained, as part of the application. And the point is, basically, this works great and for a lot of people nowadays. And when we assuming a constant number of users, this is a thing that will work. And basically, they do what they do, or what they should do, I would say. It's easy to deploy, no specific infrastructure needed. Most of the people are able to maintain. It's easy to use. And if you want, you could vertical scaling these applications. But in some parts of that kind of application or that type of application bothers me a little bit. It's not horizontally scalable. Most of you guys looking for horizontal scaling, and the reason why this is not, I think this is not possible, is the fact that this type of application is a stateful application. Eclipse Store is directly embedded, and that makes the state, and we are not able to scale it horizontally. But there are two additional points that are quite interesting. The first one, this type of application is not fail-safe. What does fail-safe mean? Who of you is able to explain what does fail-safe mean? Yeah, that's right, in a way. So that means basically, even when the pod goes down, you try to, I missed the word, try to keep the impact as low as possible. I think that's the point of fail-safe. It does not mean the application has to run as normal when the pod goes down. That could be possible, but it's not the direct meaning or the meaning per definition of fail-safe. Try to impact as low as possible. And there is no high availability. And this is also interesting. Who of you knows the definition of high availability? Again?
Functionality should work regardless of fallen instances. So each function of your application should be available for every user anytime.
That sounds like fail-safe, I guess, a little bit. And I think that's yeah, you're right. Also, in a way, the point of high availability is it doesn't. Also, in an increasing amount of users, your application has to provide the same performance and latency. Doesn't matter how many people are accessing, or doesn't matter how many requests are going to your application. That means high availability. So because otherwise it would be fail-safe. But in a way, you are right. Both topics goes together a little bit, but let's talk about this later on. Okay, monolithic applications. We knew the pros and cons of that. What is the next thing we could do? We could do something like this. We all knew this stuff, a 3-layer, I would say, or I don't know how to call it. A question would be: is this still a monolithic application, or is it? Do we talk about microservices now? I don't know. I think it's on you to define that. But let's talk a little bit about this. We have the first layer on top here. This is the UI layer, I would say. Could be a React, a Vue.js, an Angular Vue, or could even be a Vaadin Vue. A little bit different, but it could be a Vaadin Vue. That's okay. In the middle tier, or the second tier, we have our classic application server. Could be Spring application, Spring Boot, Helidon, Micronaut, a lot of stuff could be possible there. And we have one application in that special case. I used Micronaut or Spring or Helidon application with Eclipse Store in it, with our MicroStream storage. But this could also be any database on the market, right? So this is classic database structure. But in that case, it's kind of like a data provider. It provides the data via REST to all the clients who are connected to these data storage. So this is also working great nowadays. It's more flexible than the first example. It's also more scalable, and there is one important thing on layer 1 and 2. It's the stateless thing. These two layers are stateless. That means there is no information within those application that defines a state. And with that, in that case, that makes it possible to scale it horizontally. That means we could have millions of, let's say millions or thousands or hundreds of nodes in that case. But what about the layer 3? Layer 3 is still stateful, not fail-safe, and also not high availability on the layer 3 because it's stateful, and we have to find a solution for that. And one solution could be queuing. So let's say we have a queue in between the clients and the storage itself. And by queuing those data, it's possible that when the machine goes down and has to restart, then the requests are queuing and until the machine is up and ready again. That could be a possible scenario, but that works good for fail-safe, but not for high availability, right? So we don't have a problem here in that case. Let's move on. And this is the next step, and this is the point we want to talk about, is replication. Replication is, I would say, if you want to do this by your own, it's the door to hell, because there are so many issues on replication, and I only want to explain some of the issues, not all of them. They are too detailed, but the most important ones we want to talk about. Okay, but this is also, on the other hand, it's a great solution because it provides you everything. It provides you fail-safe, high availability, load reduction. That means when you spread data to all the nodes, you prevent one node from overwhelming by data, for example. There is efficiency. That means the load balancer is able to decide to choose a node which is not burden, so that can respond a good performance to the users. So a lot of good things here, but there are also a lot of different things here. First is it's highly complex. There is you will see that later. There are many things you have to know about clustering or replication. There are some issues where you can have data loss or data inconsistency. And of course, multiple servers, a lot of maintenance is required, and that creates a lot of effort to handle those architectures. And to be honest, in my opinion, most of us are not able to build a replication, a proper replication, and provide it to many people. And to be honest, it doesn't have to. So no one of you should maybe create a replication like this. And that is the point. What are you guys all doing? You buy stuff which contains a replication already. So there are many solutions on the market that provides replication out of the box. And this is the point where the MicroStream cluster comes into play. Okay, but even if you buy or if you use software as a service for replication, you have to consider a few things. The first one is, what type of replication should I use or do I need? Have you ever heard this? Asynchronous and synchronous, and what it does? So asynchronous means the write requests are non-blocking in a way, I would say. It's not the classic non-blocking stuff we talk all the time, but it's non-blocking in a way that you will get a response before the replication of the data happens. That means you send the data, you have a request, you will get a response, but you never know if the replication is fast and done successfully and stuff like that. So you only know, okay, the request goes to the server and that's it. And that is different to the synchronous way. You will get the response after the fully replication of the data on your cluster, on your application. To be honest, the asynchronous stuff is the most common way that you find on the product because it provides the lowest latency of all solutions, I would say. Let's move on to the next keywords. What architecture do I need? So there are single leader architectures, multi-leader architectures, and no-leader architectures. One question first. Does any one of you knows a technology which provides a no-leader architecture? Do you know one? There is? Okay. Okay, someone else? J groups. Okay, not true. Okay. It's also interesting to know what means a no-leader architecture. That means that every node in the replication or in the cluster is able to receive write requests, and they do some replication behind the scenes. So,
Two technologies. First, as a custom.
yeah.
High availability discovery service inside Deutsche Bank.
Okay, and there is another one. It's DynamoDB from AWS. It's also working on a no-leader architecture. But also in that case, the most common thing we see is the single leader architecture because it's the easiest one to handle. And why is it the easiest one? Because there is the risk to lose data in that case is the lowest risk. You will not have data loss at any case. Instead of having multi-leader, that could lead to data loss or data inconsistency if objects are wrong configured or stuff like that. Okay, so single leader architecture. What strategy do I need? I will call it strategy, strong consistency or eventual consistency. That's also interesting to know. Let's talk about single leader architecture. I create a request to the server. The replication is ongoing, but what happens if someone accesses the same data? And the point is, on the eventual consistency side, you will be able to get old data, I would say. You will not notice the change in the background because the load balancer leads you to a node which is not replicated. Then you will get old data. That means eventual consistency, but it provides the lowest latency in that structure. Otherwise, the strong consistency, it has high latency, but you will get always the newest data. There is no stale data at this case. I would say eventual consistency is the most common version you will find on the market. Okay, and in the unlikely case, you want to do it by yourself, you have in addition to deal with all the infrastructure stuff, Kubernetes, and you have to maintain a lot of stuff, backups, monitoring, logging, security, and so on and so on. There are many different things you have to do. So in my opinion, my conclusion for that is it's always best to use, or most of the time, it is best to use an existing system because functionality out of the box, but you have to decide which one. Just choose the right system for your needs and dealing with pros and cons in that case. I think that's the conclusion of all the talk about replication. Okay, let's talk about the MicroStream cloud or cluster. The idea of that cloud or cluster is that we have a central point of hosting your application. Many of you don't want to deal with infrastructure, or you don't have the people who can handle the infrastructure for you, and then it makes sense to have software as a service point where you can add your applications and you don't have to deal with infrastructure. And the idea is also not to provide only one type of cluster instead of having multiple cluster types that we can provide in the end. And that's the idea behind our cloud solution. And of course, hiding you from all the complexity we talked about, and especially to hide you from the infrastructure, dealing with security, dealing with Helm charts and stuff like that, and also with Kubernetes. And to provide you monitoring, logging, backup, and all that stuff fully managed within our application. That's the idea. Some of you might say, okay, that sounds interesting, but I have no idea how this could be worked with a framework like MicroStream. How is that possible to have a framework in my own application where I define my own data structure? MicroStream or Eclipse Store is not a server. How to cluster this? How could this work? I think the answer is standardization. Is my favorite word, I would say. In German, we say Standardisierung. It's sometimes easier to say, but standardization, okay. You have a look like this, or let's have a look at this, how our applications in our cluster could look like. We have on the left our basic frameworks. We support Spring, we support Micronaut, and we support Helidon. And on the other side, we have our REST interfaces. These interfaces are also quite standardized, and they should work. And then we have, in the middle, we have two things. We have the MicroStream Cluster API, so that helps you to clustering things. And we have Eclipse Store on the other side. And in the middle, you can put your business logic. And you can add your streams, you could add your REST implementations, your merge logic, and so on. And let's have a look at this. And let's talk after the demo about let's talk about the structure and architecture. Okay, let's start on the front end. So whenever you access to our cloud, you will find this welcome screen, and there are some tabs on the left side, and during the time they will definitely increase with more functionality and so on. But in this version we see our home tab. There are some stuff you need to know, some news and videos and documentation and getting started and stuff like that. Then we have one screen which seems empty now, but it provides you the templates you need that will work in our cluster. So that means the first step you have to do is you have to create your favorite template. That means you have to choose the Java version, then you choose the template itself, even should it be a Micronaut template or a Helidon template. You will be able to choose the right version of that template. Then you also be able to add some more. Are you able to read this? But yeah, you can choose the package name and the project name, and after that you will be able to download a zip file, and then you can import the zip file to your IDE of your choice and can do further development on that project. So I prepared that for you. So this is my project on my GitHub account, and I already imported it to my IDE. So let's move to that IDE. Okay, this is the project, and I already opened the classes which are relevant for you for now. Let's start at the DB class, and this is where MicroStream, I would say, or Eclipse Store starts. We need one root object. That's always the same. So we need one root object on top of our graph. This is the entry point of the storage, and we have to hand over the root object to our cluster storage manager. And that's why we add the new root object in that case. Nothing more is interesting in that class. You will get this automatically. You don't have to code this. This is included in the template. The next thing your job you have to do is to define the data within the root object, because this is part of your data model. So you will be able to define your classes, your structures, your collections. You can use hash maps and stuff like that. this is the start of your object graph. And you have to define it within your data root. In my case, I created one list of products, and what else we have to have is one, for example, here we have one product class or Pojo without any annotation as expected with MicroStream, and we want to have a list of products in our application. The next thing which is also interesting for you is the controller class, and this is the place where your REST interfaces are defined, or the interfaces to your data structure. And this is also really straightforward. This is normal Micronaut stuff or Helidon stuff, and you will be able to define your interfaces here. And that's all you have to do. There is only one class which is also already created in the template. This is the entry point for the cluster to get access to the storage manager. So, and this is needed because the cluster needs to know what happens inside your nodes for replication purposes. Okay, so now we created our application. We moved it to GitHub. I've already shown this, and now what's next on the cloud side?
Maybe short question.
Yeah, of course.
Regarding the root object or the
Yeah.
data root, is it possible to create a multiple root instance to the storage?
Yeah, it is possible, but on the technical side, this could help. On the business side, I don't know if this is really necessary, because you could define another structure below the root object. This is also possible. So you won't have any advantages of having multiple roots. So, but it's basically possible. Another thing which is possible, you can create multiple storage manager. This is also possible. Then you have multiple roots and separated graph objects, or separated graphs, I would say. Okay, so as I said, we committed it to JIT, and where is my cloud? Here is it. Okay, so this is the part where I can add a cluster, and I could choose different cluster provider. For now, only AWS is available, but we are working on spread this to different cloud provider, Azure, and so on. So let's start on AWS, and then you have to choose the cluster tier. So also, as I said, there are only a few cluster tiers available, but we are working on adding more and more cluster sizes and replication sizes. But for the moment, we only have small and micro for testing purposes, because it's important to define the right size for the cluster for best performance and using things. You have to know that the cluster consists of multiple load balancers, and we have to choose the right amount of load balancers and so on. That's important, and therefore we have to check every cluster tier best to see the performance. Okay, let's choose one. Doesn't matter one. Let's choose the small R2. R2 means there are two replication. That means one reader-writer node and another reader. Provisioning means we have to define a cluster name. It's not that important. The application type we want to add. And then there are two possibilities to provide your project. The one is via URL to your GitHub, for example, or to your Git repository. And another one, you will be able to provide the draw file. So in our case, we use the GitHub link, or so let's do so. Let's add that repository. Choose the branch of the project. And then we say next. Then we could add some backup and security stuff. we are able to define the interval of the backup and the amount of kept backups at the end. Then we have some authentication stuff that could be filled, and we provide also, especially for AWS, the private link functionality. That means your data will not go through the internet, and especially when you have your own AWS infrastructure, you will be able to only have AWS internal traffic. That increases the speed and so on. So you will be able to enable this. And last but not least, there are possibilities to create proxy settings, and that is a special thing within our cluster. The point is, in a way, you have to define which is the writing node, or you have to define where the writing request should go. And you can do this with different strategies. The first one is to use the normal HTTP methods to define which one is a write or a read request. But there are also possibilities to say, okay, there is a specific root URL in the URL, a specific word within, or we can use a special header value to define which call is a writing or a reading call, and that's all we have to do. And after that, we can create the cluster, and that needs a little bit, around 5 minutes. That's too long for me now. I already created one here, and this is the same. That's the same configuration. And let's choose the Postman here, just to get the list out of my cluster. Yeah, nothing special on that. It's a normal, really straightforward REST call. And this is the way how our cluster works in the end. And as I said, in the next tiers, you will be able to define how many nodes, for how many replications, 4, 8, and so on. Okay, let's move on the presentation side. Here we are. Okay, so what we provide at the end is an asynchronous replication on a single leader cluster with eventual consistency. That is the first product we launch on our cloud. But we are already working on a solution which is strong, consistent, and made for big data replication. That's the next step, the next cluster we provide. In the first one, we provide failover, high availability, no data loss, no data inconsistency. And I think the advantage to all the others we provide, you can configure your own merge strategies. That means because of the fact that you provide your own application to us and we do the replication for you, you will be able to add business logic or to use a different merge strategy on your application side. And that's the same. Reads and writes can contain business logic, because everything what happens within your interface is, let's say it's your business logic. It's streaming logic and stuff like that. And it's up to you to use it in your own way. And you are able to returning data as you want. You define the DTOs and you define the result sizes and so on. That means you will be able to find the best performance at the end for your REST endpoints within that cluster. Okay, that is the architecture of the cluster itself. That means we start at the load balancer in front. That could also be multiple load balancers on higher tier sizes. We have one writer node on the left, and you see the different replicas. Each replica has its own storage. We have a backup node in the background, and we have some event streaming stuff to do the replication. And whenever we have a read request, it looks a little bit like this. So the load balancer takes care about to distribute the read requests, and we have a different system on the writes. So whenever one write comes in, it goes directly to the writer node. The writer node stores the write, goes to the backup, and then distributes the data to the different reader nodes. That's basically how it works. It's quite easy, but you will find more to that on our documentation. Okay, what features do we have for now? So as I said, we provide the AWS platform. Supported frameworks are Micronaut and Helidon at the moment. We support Git and jar upload, but there will be more functionality in the future. We provide individual tier sizes, CPU, RAM, memory, and so on. I think that's quite clear. We also provide an auto-scaling function. That means this is based on CPU and RAM. So you will be able to decide, okay, I want to start mostly on a 1 CPU, 2 gigabytes of RAM machine, but you can add the possibility to scale if needed to higher RAM and CPUs. And this is auto-scaling, vertical scaling, I would say. And on the other side, we have basic authentication support, private connection support with AWS Private Link, individual backup strategies, and so on. A lot of stuff is available for now. What's upcoming next? So what is on the roadmap? The next steps will be to open that solution to Azure Cloud and Google Cloud. That are the next topics. Then we want to add the Spring framework, also to provide you the possibility to add Spring Boot applications to that cluster. And also interesting is to provide CI/CD via Jenkins or GitHub Actions to deploy your cluster or your applications to our cluster. Auto-scaling in a horizontal way, we planned that also, so that you will be able to say, okay, if it's needed, then the cluster will automatically scale up more nodes horizontally. Then there is a scale to zero scheduler. That means it will be possible to say, okay, please start the cluster on Monday, 8 o'clock, for example, to save costs and money. And as I said, in far away, we will get the big data cluster with the gigantic workloads and data throughput. But this is the next upcoming product within our cloud. Okay, I think it's time for your questions, and hopefully there are a lot of them. So let's start here. Yeah.
What I still do not understand is how can the single leading cluster be fail-safe if the writing node is offline or down in this space?
Yeah.
Clear to my cluster.
I think it's a mix. It's a mix on queuing the data and waiting for the writer node. In that special case, in our case, when the writer node goes down, the next reader node will automatically becomes the new writer one, and that is direct. Yeah, that's directly it switches to the writer node. Okay. So. I didn't get it. That's a good question. Somewhere, I would say somewhere, I'm pretty sure this year. Yeah, maybe, but yeah, something between 2 or 3 months, I would say. Okay.
Regarding updating the application,
Yeah.
If I understood it correctly, if we make some changes for our business logic
Yeah.
code, we have to provide these mapper
Mhm, mhm.
classes. Is there any support in doing kind of a copy of our cluster to do these migrations?
Yeah, there is. I think the thing is, we follow the basic rules of MicroStream. So whenever you change something within your interfaces or REST interfaces, I think that's easy to have. You just deploy the new application. But if you have some data type or data structure changes, then it depends on how big is the impact on the data structure. And there are two options, I would say. First is you will be able to create a backup of your data and start another cluster, and you will be able to upload your data to the new cluster, and then it fits. And on the lower impact stuff, you will do it on the fly. So the cluster will do that automatically in the background.
So I'd just update new deployment on my cluster.
Yeah, that's right. That's right. So the legacy type mapping of MicroStream will do that in the background. So, for example, if you add a property or you remove a property or rename some properties of that, that's not a big deal. So, okay, there was another question. Yeah.
If I understood right, then our application will be deployed at a central cluster. What about testing and debugging?
That's a good point. Let's jump into the UI. I missed that. Sorry for that. You will be able to see the details of the cluster. So this is kind of like a monitoring. We have some tools in the background like Kibana and stuff like that, and we provide you all the information you need to know about your nodes, and you see that here the CPU and usage and RAM usage of your nodes. And there is some more stuff like monitoring. So that means we see the metrics of your cluster, and you will get also the logs of that. That will help you to test and monitor your applications within our cluster.
Just want to add to that debugging.
Mm-hmm.
So MicroStream can also targeting not the cloud, but your local files. So you can store pretty much the same scene in local files for debugging purposes.
Yeah.
And for broad, just target them.
That's a really good point. The application you create, that Micronaut application, it can be started locally. So you can develop it locally, use your local structure to test it and debug it, and in the end you are able to decide, okay, let me just switch from the embedded storage manager to the cluster storage manager, and then you can deploy it to the cloud. And we planned one feature. I'm not really sure if it's implemented now. There is a switch within the cluster manager to say, okay, let's switch from local mode to the cluster mode. I have to check this, but we planned that feature. But I'm not sure if it's implemented now. Yeah. No, that's the platform is not open source, and also the MicroStream enterprise cluster is not open source.
Second question, can we deploy it in our private cloud?
There is, we working on an on-premise solution for that, to provide you all the Helm charts and configuration stuff for running these type of cluster within your on-premise solution, but you have to contact us, and you will get more detailed information then. Yeah.
What is the time frame for this feature?
An on-premise solution for that? Also a good question. I would say the same, something in between, something 2 months or 3 months, I think. Yeah. But if you are interested in such a solution, just send me an email, and we will be able to start that from now on. So it helps us to understand what our customers need, and it could provide a huge benefit for you to be one of the first to get this just for testing purposes. Yeah, could be great and help us a lot. Okay, another question. So visit our booth, ask more questions about that, and yeah, that's all from my side. Thank you for your attention. So come to me after that, and then we can clarify that question. Thank you.